Our next speaker today then is Adam Webster with Vadum, speaking to automated artificial intelligence, distress alerts and monitoring. Adam?
All right, thank you, Chris. I'm happy to be here today. We're excited to share our work on automated artificial intelligence, distress alerts, and monitoring. Let's talk for a minute about the problem we're helping the Coast Guard with. Coast Guard watchstanders work in command centers. They continuously monitor the VHF radio distress channel around the clock. Shifts tend to be long, on the order of 12 hours. And they generally need a tool to assist them with rapidly understanding and effectively responding to incoming calls. Our solution helps to reduce manual labor, provides key call insights. It's aimed at improving their decision making. A key element of the solution is addressing hoax calls. A small fraction of all calls are hoaxes, but they're more than just a nuisance. They distract watchstanders. They waste costly search and rescue resources to the tune of millions of dollars a year. And they generally put rescue teams or can put rescue teams at risk. So a core element of our solution is to alert watchstanders to subtle signs of a hoax call. We analyze incoming calls and provide immediate suggestions about the legitimacy of the call. So where do we see this technology being applied? Primary application is for Homeland Security, specifically Coast Guard watchstanders in command centers. Our commercialization focus is adapting core elements of our solution for 911 call monitoring, particularly with a focus on swatting detection. We feel the core mechanics and much of the R&D can be applied to the 911 domain, with a focus on detecting deceptive callers. We've also, if you look on the right-hand side of the slide, identified some adjacent potential DoD applications, uses such as fake intelligence detection or interrogation support could potentially benefit from elements of our approach as well. There's some additional possible commercial applications like voice phishing detection or vishing. All these applications have an element of deception detection, akin to what we're doing for our Coast Guard hoax distress call analysis. What does the Coast Guard use today to characterize VHF distress calls? There's a system called Rescue 21. It's used to monitor and respond to VHF distress calls. Watchstanders listen from Coast Guard command centers. If you take a look at the image on the bottom right there, the system's got broad coverage, covering all the coastlines and major waterways. Rescue 21 provides a key feature, and that's lines of bearing that help give a sense of a caller's geographic location. Notional example of that's in the figure on the top right. This can be used for dispatching search and rescue resources, but it can also be used to an extent for some hoax call detection. For example, hoax calls that originate over land, or calls that originate over land may be suspect, or if the coordinates relayed by the distress caller don't match the lines of bearing, that can also be suspect as well. Today, hoaxes are addressed manually. Watchstanders must articulate a rationale for suspecting a hoax and run that up the chain of command. Let's talk for a second about the phase 1, phase 2 SBIR topic requests. The original solicitation stated that the solution should use artificial intelligence to monitor the radio distress calls and differentiate hoax calls from legitimate calls. Phase 1 for us was fleshing out the concept and showing feasibility of our approach. We're currently halfway through our phase 2 effort. That's developing a prototype that will be delivered for a limited user evaluation by a subset of DHS and Coast Guard representatives. Some core objectives are listed in the table on the bottom there. One of the things we want to do is just increase watchstander effectiveness overall, and part of that is reducing the mental load or cognitive burden, if you will, on the watchstander that's listening for long hours at a time. Also assisting by reducing the amount of manual labor that a watchstander has to put into processing and understanding a call. We're going to deliver a reliable hoax detection capability. And along with that, it's not just a thumbs up or a thumbs down. There's a hoax present. We are providing supporting rationale for why that decision is being made. Automatically triaging calls. There's not just distress calls on the VHF 16 channel. There's also other traffic as well, some of it non-critical in nature, weather updates, safety broadcasts, things like that. Part of our solution is to automatically triage the calls so that we focus the watchstander on calls that are more critical first. And then additionally, where we can, we're trying to provide additional contextual understanding. We're currently working on showing the feasibility of intoxication detection. And in the future, we'd like to build in elements that detect repeat callers. Here's a high-level overview of our solution. The left-hand side shows potential system inputs. Middle shows our core system components, and the right outlines why those components are useful. I'll just start on the left-hand side. Today, we're listening to the VHF distress channel. Tomorrow, that could include other audio sources, such as landlines, cell phones, 911 call centers. We call our system match. Core match elements are shown in the middle. These include things like automation. We produce a transcript of the call, highlight keywords within that transcript, provide not just the original audio, but enhanced speaker audio, as well as isolated background audio, so you can listen to sounds in the background. The intent of all that is to reduce the amount of manual labor that a watchstander has to go through when processing a call. Like I talked about earlier, we also provide call type detection. This is quickly alerting a watchstander to more urgent or serious calls in nature. And then core element of the system is hoax analysis. We do that from 3 different perspectives, if you will. We look at the word choice of the caller in the transcript that we generate. We look at characteristics of the speech, and then we listen for clues in the background sounds as well. We're currently working on showing the feasibility of intoxication detection for added context. And then some future work for things like repeat caller detection are also on the list here. The core technology is composed of a mixture of machine learning models and signal processing. System performs analysis in near real time when running on a standard desktop or tower computer, and it's amenable to cloud-based deployment. This is a snapshot of our prototype user interface. You can think of it as a central AI-enabled point that allows the watchstander to listen to calls, receive call analysis results, and review call information. It does this in a way that makes information easy to process and just facilitates or helps facilitate rapid decision-making. Our solution puts an emphasis on a rationale for the decisions and tries to put the call into context. So, think of this as an assistant that's helping explain the incoming call and allows the watchstander to make a more informed decision more rapidly. It's not just a thumbs up, thumbs down. It's a hoax call. It's not a hoax call. It's providing additional context and understanding around the incoming call. If you take a look on the user interface, I know it's a little bit small there, but if you take a look on the left-hand side, there's a log of incoming and past calls on the left. For a selected call, you can play back the call. You can hear enhanced speaker audio, background audio, read the call transcript, and that'll have keywords highlighted within the transcript, so it draws your attention to more important elements more rapidly. High-level analytic results are shown on the right-hand side. That includes a summary of the call type, as well as the legitimacy or hoaxiness, if you will, of the call. And you also get voice, words, and background analysis results and a summary of key findings. Here's a recap of our solution with a summary of some of the key features. So reducing manual labor is important to us. So the call automation that I've talked about does that. That's just detecting the presence of a call as it's incoming. Enhancing the speaker's speech, background audio, automatic transcription, highlighting of keywords. Call type detection tells a watchstander when a call is critical in nature. And then the hoax detection is performed by looking at the call from several different perspectives. That's word choice, speech characteristics, and background sounds. And a key element of our solution is that it provides a rationale for the decision and tries to add context for the watchstander to enhance their decision making. Let's compare our solution with some other available capabilities. Left-hand column lists features of our solution. That's hoax call detection, call automation elements, call type detection, hoax analytics through the lens of word choice, voice and background audio. Compared with Rescue 21, Rescue 21 does some of the same elements of call automation. It's providing the audio in the first place, and then allowing for recording and playback capabilities. And it adds some context through lines of bearing to an extent that could be used for detecting some hoax calls. Looking at commercially available tools, there's not a lot in this arena. There's some generalized voice analytics out there, but they're not focused on hoax call detection. So if you think about things like call center monitoring and sentiment analysis, those are commercially available tools that are out there. They're not focused specifically on hoax calls and deception detection the way that our system is. So where are we with the current state of development? We started phase 2 a little over a year ago, having shown phase 1 feasibility. We delivered a baseline capability demonstration in May of this year that included all of the key system elements. It's call automation, call pre-processing, call type detection, hoax analytics, a UI prototype that you saw on one of the prior slides. We'll be delivering an updated prototype in February of next year, February of 25, for a limited DHS and Coast Guard evaluation. Just talk about the company real quickly. Our company is called Vadum. We've been around for about 20 years now. We're based in Raleigh, North Carolina. We've got just around 100 employees. Most have advanced degrees, and we're focused on DoD and DHS applications across kind of a range of technical domains. I'd say in terms of core competencies, we're generally good at prototype development and maturing those prototypes into deployable solutions. We're here today because we'd like to hear from you. I think our solution can be adapted to 911 swatting detection without too much effort. I think our solution can help address needs related to rapidly understanding and effectively responding to incoming calls. Core R&D and core processing elements could be adapted to 911 call centers, call swatting detection. We'd like to hear your needs and discuss how we can help address them. So we're just generally looking to connect with state and local public safety partners. So if you're out there and this sounds interesting or sounds like it could be adapted, please reach out. We'd love to hear from you. Just a quick note on where we are programmatically and where we want to head. We were given up to $1 million for a 2-year prototype development effort. We're about halfway through that. Starting in FY25, we're looking to do 2 things. 1, perform operational evaluations on a limited scale. And 2, address some enhancements or use cases that were identified during the course of the phase 2 effort. Starting in FY25, I think we'll be poised to look at adapting core technology for swatting detection. Here's our contact information. I'd like to hear from you. Just give us a call, send us an email. We'd love to talk or give you a demonstration of where we are.